Hello guys, welcome to my channel. Myself K. Santosh. I am studying in Sri Venkateswara College of Engineering, Bangalore. Today our topic is numerical on superposition and Thevenin's theorem. The Wheatstone bridge in the circuit shown in figure is balanced when R2 is equals to 1200 ohm if the galvanometer has a resistance of 30 ohm. How much current will be detected by it when the bridge is unbalanced by setting R2 to 1204 ohms? Here is the circuit. Here is the given circuit. In the question, they have given that Ig equals to 30 ohm. To find out the current of this galvanometer, we have to open this circuit. First thing, we have to find out the I1 for this loop. That is 120 volts divided by 900 plus 600. For this voltage drop, we have to find out that is this I1 into this across the voltage drop resistance. Here we simplified and we got that 48 voltage. For this second voltage drop, first thing we have to find that I2, that is 120 into 120 divided by 1204 plus 800. Here we should not consider 1200 as that in question they have given that we should consider 1204. So voltage drop across VB, that is equals to 800 into I2, which we will get that 47.9 volts. For Thevenin's voltage, we have to find that VA minus VB. That is VA we got 48 volts and VB we got 47.9. That is VAB equals to 48.48 minus 47.9, which is equals to 0.096 VAB. This is the VAB value, which we can also call as Thevenin's voltage. To find Thevenin's resistance, first thing we have to do that current source is short and current source is open and voltage source should be shorted. As to find the Thevenin's resistance, we have to do that current source is open and voltage source is shorted. After doing this process, the circuit is written again. First thing we have to find that RA, as these both are in parallel. So these both are in parallel, so we have to calculate that 900 into 600 divided by 900 plus 600. For second resistance RB, these also are in parallel. So 1204 into 800 divided by 1204 plus 800. We got the value as RA is equals to 360 ohm and RB equals to 480.63 ohm. As RAB, we need Thevenin's resistance, that is also called as RAB. RAB is equals to RA plus RB. As we found that RA and RB, we have calculated. RA equals to 360 plus 480.63, which is equals to Thevenin's resistance. We find that 340.63 ohms. After we finding Thevenin's resistance, as we found out that the voltage, Thevenin's voltage and Thevenin's resistance, we have to calculate the current for that galvanometer. So again we rewrite this circuit. Thus IAB, that is for this current for the galvanometer, which is equals to Thevenin's voltage by Thevenin's resistance. Thevenin's voltage we got the 0.096 divided by 840.63, which is equals to 1.1417 into 10 power minus 4 ampere. Our next question is, for the network shown in figure below, apply superposition theorem and find the current I. This current we have to find by using superposition theorem. as we written the circuit in the question given. First thing we have to do that current source is open and voltage source should be shorted or closed. Again this circuit as rewritten. Here this resistor and capacitor are in series connection. So we have to add both these two. So that is 4 minus 2j. Again, this resistor and inductance are also in series connection. So we have to add these two. That is 8 plus 10j. Again, this circuit has been rewritten. After writing a circuit, again these two are in parallel. So that is 8 plus 10j into minus 2j divided by 8 plus 10j minus 2j. This is the parallel formula. Again we have to rewritten the circuit. Again here these both are in series connection. So we have to add these both. After simplifying we get this equation, that is 17 by 4 minus 17 by 4j. That is z equals to 6.01 angle minus 45 degree. This we can get in calculator by calculating in calculator. That is, we have to find that IA. According to Ohm's law, we can find the IA value. That is, IA equals to V by Z. Z is also called as resistance. V is J20. Again, and Z is, we have calculated, that is 6.010 angle minus 45. After simplifying, we get this minus 2.35 plus 2.35J. Again after simplifying, we get that IA value is 3.327 angle 135 degree amperes. Again to find IB, the voltage source is open and current source is shorted. Here you can see in the circuit diagram. To find I1, I2 and I3, we have to apply a KVL loop. Here there are 3 loops are there. For the third loop, I3 already given that 5 amperes. So we have to apply only for first and second loops. By applying KVL loops, we get the equation that 8I1 plus I1 minus 5J10 plus I1 minus I2 of minus J2 equals to 0. This is the first equation for the first loop. Again for the KVL for the second loop we get this equation, that is I2 minus I1 into minus J2 plus I2 minus 5 minus into minus J2 plus 4I2 equals to 0. This is the KVL equation for the second loop. By simplifying we get this equation, 8 plus J8 into I1 plus J2 I2 equals to J50. Again for the second loop, J12I1 plus 4 minus J4I2 equals to minus J10. After getting those two equations, we have to again solve by matrix method. That is, IB equals to I2 equals to det of 8 plus J2 J50 J2 minus J10 divided by det of 8 plus J2 J2 again J2 4 minus J4. By simplifying we get this IB value, that is 2.897 angle of 23.76 degree amperes. Thus we got IA and IB value. Since IA and IB are flowing opposite direction, that is I equals to IA minus IB, that is 3.327 angle 135 minus 2.897 angle minus 23.96. Thus after simplifying we get the total current value, that is equals to 6.1121 angle 144.78 degree amperes. Thanks for watching guys. Those who have not subscribed, please subscribe and like my channel.